We'll get it kicked off with our CEO and co-founder, Alex Bouzari.
You know, I'm always reminded that this whole AI thing, we talk about AI and we say AI is this and AI is that, as if there wasn't something before AI. Well, what existed before AI was HPC. AI is HPC. So for those of us who were here decades ago when it was called HPC, well, we created this. This AI universe which exists today is thanks to all the people who created HPC, which then led the way into AI. So just very, very important, I think, that people need to realize that just as it was the case with high-performance computing and is today the case with AI, it is all about data. And it's about extracting intelligence and value out of that data, whether it's for scientific discovery in government labs, research facilities, and academia, or if it is insight that leads to the creation of better products and services and innovation for enterprises and the industry. It is all about the data. And it's about creating insight from that data, which leads to better decisions, better science, better discovery. So just looking at the history of all of this, as I was saying, AI is really HPC. So DDN started in HPC, and we were fortunate enough to have some very, very loyal, great customers who were doing things at massive scale. And the challenges in HPC back in the day, 2 decades ago, was that there were massive compute capabilities, but those massive compute capabilities had data storage that did not keep up with it. So we came along and our customers basically told us exactly what they needed out of the data framework. And so we created the technology that kept up and accelerated the frameworks that were being utilized in high-performance computing. Well, fast forward a bunch of years later, NVIDIA came about and said, well, we want to showcase the capabilities of our infrastructure. We want to demonstrate what one can do with NVIDIA technology, with our GPUs, with our software layer. And so we want to stand up a reference architecture which shows what is possible, what can be done. And they had clearly the GPUs, they had the ecosystem with CUDA, they had the software layer, they had the networking capabilities with InfiniBand and Mellanox, but there was no data storage. So they looked far and wide at all the possible technologies out there which could demonstrate what NVIDIA SuperPODs could do, and they chose DDN. Well, here we are 7 years later, and DDN is still the only technology relating to data that is deployed internally at NVIDIA. So I guess we must be doing something right in the enablement of AI and the enablement of large data sets. Now, DDN, we are a bunch of engineers. Fundamentally, we listen very closely to our customers. We try to understand as best we can the challenges that they're faced with in deploying the massive infrastructures that are required to give them insight into the use cases that they need. And we develop technology, we create innovations to make our customers' work better, faster, more cost-effective, but more enabling. So it's all about that. And as a result, we are powering more HPC at scale, more AI at scale than anybody else. So I'll just give you 2 bookends to that. One bookend is NVIDIA. We talked about it. DDN is the only data intelligence platform, the only data storage technology deployed internally at NVIDIA. The other bookend to that is xAI. xAI, massive deployment, 100,000 plus GPUs, and DDN is a data intelligence framework that is deployed and enabling to that. So from that, take it across use cases and market segments and geographies. We are powering hundreds and hundreds of very large-scale deployments in high-performance computing, in AI, across market segments. Now, why is that important? The reason why it's important is that when you think of these infrastructures which are being created, and it doesn't really matter whether they're being built and deployed on-premise in data centers or in the cloud, NVIDIA is an enabler to all of this, so are other organizations. So the infrastructure is getting laid out, and the infrastructure consists of compute and processing, and obviously the software layers that are feeding all of this. But for that to really function, and Jensen said it better than we possibly could, said, well, DDN is providing the fuel to the brain that is required for all of this to function. So we are the rocket fuel. The infrastructure is there. There are lots of amazing companies creating great, great things. We are providing the rocket fuel that delivers better, faster, more accurate insight from these massive data sets in real time. Now, data intelligence is really absolutely key and critical in helping this transformation, in helping this enablement, in helping this acceleration. Why is that? Well, it's all about data, right? So, and data resides in a variety of places. Data resides within organizations and enterprises. Data resides out there in the public domain. Data is in the cloud. And all of this data, whether it is text, images, audio, video, PDFs, what have you, needs to be brought in, it needs to be curated, it needs to be ingested, it needs to be processed and analyzed in order for insight to emerge on the other side of it. So I think that's a given. Highly distributed data sets in vastly different formats in order to achieve real-time insight. Well, there are some challenges to that. Well, how do you deal with the fact that it is scattered everywhere? It is in AI frameworks, it is in software suites, it is disparate in nature. How do you unify it? How do you bring it all together? And how do you analyze it in a way that is truly enabling, that is as real-time as possible, and can be done cost-effectively? So what are the attributes of the right data intelligence platform to be enabling to all of this? Well, you have to be able to access all of it. These are not like the old days where you could simply tier your data and say, well, there's data that I'm going to access very frequently, so I'm going to put into very high-speed media. There is data that I won't really need a whole lot, so I'm going to put it into cold storage, and I will tier it. In the world of real-time insight and real-time access to content, everything needs to be available and accessible all the time at very, very high speed. So what is it that the right data intelligence platform for today's world needs to deliver? It needs to unify all of this data that is out there. It needs to provide real-time insight into it. It needs to deliver high levels of efficiency. What are the main challenges today that are in the way of the acceleration of content enablement by AI? Well, there aren't enough GPUs out there, right? And the way things are going, this is going to be a long-lasting challenge that needs to be faced. So not enough GPUs, access to GPU is difficult. Not enough data center space, you need more data center space. Not enough power. So in order to better address these challenges, you need a data intelligence framework that can alleviate these things, that can deliver more capabilities out of the GPUs that are being deployed, whether in data centers or in the cloud. You need to shrink the square footage in data centers that are being utilized for these things to free up space. You need to lower the power consumption simply because there isn't enough power out there to take care of all of this. So that's what it really needs to do. Now, if you look at the flow and the complexity of the flow, by the way, this is an NVIDIA slide, so we gave full credit to NVIDIA for all of it, but we like the fact that it highlights all the areas where data is important and where data intelligence is critical. So at one end of it, on the left side of it, you have the data coming in. Again, images, text, audio, what have you. It's coming in. It needs to be processed. It needs to be analyzed. You need key value stores associated with it. You need vector databases. You need an object store that can operate at massive scale with very low latency. So all of these things need to happen. Then you need to store it very, very efficiently, again, in a highly distributed manner. And then at the other end of it, you get insight, which helps you make better decisions, helps you create better innovation, helps you progress all of the areas where data is critical. And all of this needs to happen continuously in real time. And that's where DDN is highly enabling. So we take that workflow and we say, well, these are the areas where we can deliver value. We can ingest the data significantly faster. And so the time to insight shrinks on the one hand. On the other hand, you free up significant cycles so that GPUs can be utilized to their highest levels of efficiency. You accelerate those GPUs. So again, insight faster, more value quicker. It's networking. At these massive scales, networking is becoming a fairly significant challenge. So accelerating networks and freeing up some of the bottlenecks in the network are very, very critical. And so looking at the problem, in order to make all of this work well, you need to solve these challenges in the stack, meaning the stack, you have the application layer, then you have GPU, compute, networking, and data. So in the stack, it's an acceleration and an enablement in the stack, but also above the stack, which is where a lot of the value resides. Above the stack, meaning the AI frameworks, the software layers, the large language models, the inference, and the Gen AI. So it's these two things combined which create true enablement. And so another view of this, if you kind of dissect it, you say, well, yes, I have my data sets on the one end, I have insight on the other end, I have these vastly distributed, highly distributed frameworks which involve GPUs, which involve compute, networking, on-prem, in the cloud. And I need to unify all of this. I need to bring all of this together in a way that is highly enabling. And that's what DDN does. It's a software data intelligence platform that accelerates the underlying infrastructure, GPU, compute, storage, QLC, TLC, hard drives, but also accelerates the above-the-stack software suites. And combining these two things together makes us very unique in the value that we deliver to these frameworks. Now, I would like to speak a little bit about this new technology called Infinia, which we have not launched officially yet, but it's already deployed across more than 100,000 GPUs in a variety of places and locations. And it is providing this enablement in the stack and above the stack. So what is Infinia? And we'll get into the technical details of the technology that we've developed. 7 years of development, a few million lines of code, but who's counting? And what it really is, it's a very high performance multi-tenancy data intelligence platform that does a number of things. It kind of spans across a very broad range of protocols, file, object, block, so all of that. Because again, thinking of what you need to do in order to deliver insight, we said the data sources are disparate. They're all kinds of different things in different locations, so the protocols are different. So you have to support multiple protocols. On the other end of it, you have users who need to be segregated. So multi-tenancy is incredibly important. So we bring these two things together. You want to minimize the movement of data across locations, on-prem, in the cloud, because moving data is very, very expensive. It's complex. It adds latency. And not only does it slow things down, but it adds cost. So you have to minimize that, and Infinia does that. It's the ability to operate at massive scale. in the world of AI, just like the world of HPC, massive scale is what it's all about. We're not solving small scale challenges here, right? The data sets are massive. Whether you're on the LLM side of it or on the inference Gen AI side of it, you're dealing with massive data sets. So the ability to perform at massive scale, at highest levels of efficiency, is absolutely critical. We talked about data center space being just unavailable. So shrinking the data center square footage and delivering value out of a much smaller footprint is key. Infinia does that. Shrinking the power consumption does that. It's a great thing, save the planet, but it's also a great thing because there simply isn't enough power out there. So you have to do that. And Infinia does that at levels of efficiency that are far beyond anything else that's out there. And then it's the acceleration of the software layer, which is above all this. So in many ways, it's analogous to the GPU side of things. I mean, if you look at deployments that involve GPUs, you have the GPU construct, you have the software layer above that, you have the enablement of that with NIMs, microservices, NeMo, and all kinds of other capabilities. And it's bringing those two things together. Similarly, Infinia is doing that on the data side of things. Because again, these two worlds need to come together for insight to really happen. And so Infinia kind of brings all these things together. We will talk about it a lot more. Again, some of the deployments we have with Infinia are at massive, massive, massive scale. So again, think of it in the HPC pivot into AI factory types of implementations. Many of our HPC customers have already started utilizing and leveraging and taking advantage of AI frameworks and using the massive experience and data centers that have been built over many, many years to pivot into the enablement. I mean, AI is an enabler to science. It is an enabler to HPC. And so these two worlds are coming together. So in short, it is all about maximizing the value from the infrastructures that are being deployed at massive scale in data centers and in the cloud, in high-performance computing and in AI, because all these worlds are coming together. You have to be able to handle it at the edge. You have to be able to handle it in the data center and in the cloud, bring all of it together, accelerate, shrink the footprint, maximize the utilization, and by doing so, we will help science, we will help business outcomes get greatly accelerated, and we will be able to do it significantly faster and more cost effectively than what was done before. So that's kind of where DDN is in terms of enablement. Thanks to you, thanks to our customers, our business has grown very, very significantly over the years. We're powering, from a GPU standpoint, which is one way to look at it, more than 500,000 GPUs today, and that number is increasing very, very rapidly. We have deployments at the exabyte level from a capacity standpoint. We have deployments at the 100,000 GPU plus level from a scale standpoint. But the benefit of all of this, it is not to say that every customer, every deployment, every installation is at truly massive scale. But by solving the challenges and by providing the highest levels of efficiency and acceleration at truly massive scale, we're able to take that down into everything else and make sure that we deliver bulletproof stability and value at the most cost-effective way possible across a very broad range of installations. So that's what we're here for. We're here to delight you, our customers, in all of your use cases, in high-performance computing and in AI. Thank you very much.
Thank you, Alex.